Hello dear students, welcome to Sita Group of Education channel. I am Avnish Kumar Vasti. In the previous video we have talked about distance, displacement and the concept of motion. Which type of object can be in the rest in position, which type of object can be motion in position, we have discussed a lot. Here we are going to talk about motion, velocity, types of velocity and graphical representation. Let us start with it. Velocity the distance covered by a moving object in a particular direction in a unit time. You know that this is a vector quantity. Velocity is a vector quantity. It means it have direction and magnitude both. Velocity equal to displacement upon time taken. Its SI unit is meter per second. Types of velocity, let us discuss one by one. Constant velocity means at a particular point, this is the reference point, you can say that if this object moves from A to B, it means you can say that this type of velocity can be constant velocity. Suppose that its velocity is 2 meter per second. It means he covers the distance 2 meter in a 1 second. Another 1 second also he will cover the distance 2 meter. Such type of velocity is called the constant velocity. So you can say that in a linear way, in a straight line, the path, its path can be the straight line in a steady manner, velocity called the constant velocity. Next one is the changing velocity. Let us start with it. Changing means at a particular time. With respect to time, velocity changes. Suppose that this object is, he start from here point A, after that to the point B, then B to C, here 2 meter per second, in another 3 meter per second. It means in unit time this object is changing its velocity. So such type of velocity is called the changing velocity. On a circular path you can say that any object can be. Next one is the instant velocity. As the name is instant, at a point of time, it randomly change its velocity. Such type object have the instant velocity, or the velocity which changes with respect to time instantly at a point of time, known as a instant velocity. Suppose that I am going to give you one example to you. Suppose that you are at your home. Just now you have started to move from there. You have started to move at one place. Suddenly any obstacle came in your path. Then you turn. Just your reflex action, you can say that your body is due to the reflex action of your body, just now you have changed your velocity. So such type of at a point of time, if the object changes its velocity, so you can say that such type of velocity is called the instant velocity. Next one is the average velocity. If we will talk about the velocity is more than the one velocity, it have the initial velocity u. Initial velocity, it means from where you have started your journey. Next, v is the final velocity. If you want to find out the average velocity, then it can be the initial velocity plus final velocity upon 2. Such type of velocity is called the average velocity. average velocity, sum of velocities upon how you can find out the average sum of the velocities upon the total term. It means initial velocity plus final velocity upon 2. In this way you can calculate the average velocity. Next one is the terminal velocity. Which type of motion, which type of velocity is known as a terminal velocity? Let us start with it. Have you seen the objects free falling? Free falling is such type of, due to the gravity objects fall down. Any object is here, this object, object A, it have the mass m, it start to fall down. Which type of velocity it have the terminal velocity. Free falling body having the terminal velocity. So you can say that here the sir, one thing is that suppose that it have the initial velocity 0, object having the mass m have started to free fall from A point to B point, then there is a resistance, air resistance can be. So air resistance is decreasing, you can say that, but here the acceleration is from initial to the final position. This is the reference point, point A to B. If the object fall down, then here the air resistance also reduces the speed. Such type of velocity is known as a terminal velocity. If you will talk about in the vacuum, there will be no resistance. It means free fall body will fall, the object will fall the more speedy, in a more speedy way. Next one is the acceleration. Which type of thing is acceleration? Let us discuss. The rate of change of velocity is called acceleration. It is a vector quantity. Rate of change of velocity, it means there is a change in the velocity. Which type of change can be? Change can be positive, change can be negative, change can be 0. So there is a change in the velocity. So how we can calculate is, acceleration is denoted by the small a. Rate of change of velocity. How you can find out the change in any object? Suppose that you are going to find out a change in a simple way. The final value you will take minus initial value you take upon the whatever time is taken, that you will take. So in a easy way you can able to find out the change in any object. In this way, change in the velocity, how you will find out? Suppose that from your home you have started to move. A, your school as a B point. Here you have the initial velocity u. When you reached at your school, then final velocity is v. So how you will find out the change? What exactly the acceleration mean? The final velocity minus initial velocity upon time taken, whatever time you have taken to complete this journey. So in this way, in a easy way, you are able to find out the acceleration. The rate of change of velocity is called acceleration. This type of change can be in the speed and in the direction. Listen carefully. In a speed, suppose that there is any object have the speed, you are saying no, there is no direction. Change in the speed occurs, then change in the acceleration can be or not, acceleration can be or not, acceleration can be. Suppose that change in the direction, you turn, but the speed is the same, then also the change in the velocity. So you can say that acceleration can be. How? Acceleration can be in a easy way change in the velocity. It means the change in the speed can be, change in the acceleration can be. In this way you are able to find out the acceleration in a easy way. How many types of acceleration? Discuss about one by one. How many types of acceleration we have? Just now we will discuss one by one. First one is the uniform acceleration. As a name is uniform. You know that uniform, it means same way. If the change in the acceleration, it means in the same way change can be. How the same way change can be? How it is possible, sir? Listen carefully. You are able to find out the answer. Change in the acceleration. Uniform. Uniform means in a same way, in a same manner as it is. Suppose that change 2 meter per second square. This is the meter per second square is the SI unit of, you can say that, acceleration. It is a unit of acceleration. 2 meter per second square. How you will get, first thing is how you will get the unit of acceleration. Listen carefully. Unit of acceleration. How you will find out? What is your formula? Change in the velocity, final velocity minus initial velocity upon time taken. What is the unit of velocity? So that can be meter per second. What is the unit of the time? Second. This will go meter into second. What you will get? Meter per second square. Just now you will get the unit of acceleration, that is the meter per second square. Just now see types of acceleration. First one is the uniform acceleration. Uniform acceleration, as the word is uniform. Uniform means same. As in school you have seen that when schools are opened, then teachers are suggesting you come regularly in the uniform. Then you know that what exactly the uniform means, same way. Everyone is look like a same way. Same here. Uniform and the acceleration, it means you are able to find out the uniform acceleration in equal interval of time, equal change in the velocity. In a equal per unit interval of time, equal change in the velocity, such type of acceleration is known as a uniform acceleration. It is clear to everyone? Uniform acceleration means in a equal interval of time, equal change in the velocity, such type of acceleration is known as a uniform acceleration. Next one is the non-uniform acceleration. Different in a equal interval of time, there is a change, but different change in each and every equal interval of time. It means you can say that in a unit time interval there is a different change in the velocity. Such type of acceleration is known as a non-uniform acceleration. Is it clear? Next one is the instantaneous acceleration. At the instant, randomly change. Suppose that you are moving from one place to another place, from your home to a school, then you have seen randomly, suppose that in a way an obstacle entered, then what you will do? You will apply the brake. If you have the bicycle, you are riding a bicycle, then you have to, just now you will apply the, due to the reflex action, just now you will apply the brakes, then you will see what? Change in the acceleration. How the randomly changed. Suppose that your acceleration was the 2 meter per second square, then it can be the 1 meter per second square, or the less than that 0.5 meter per second square. In the such manner, the instantly randomly change occur in the velocity due to the obstacle entered in the path. In a such manner, such type of acceleration is known as a instantaneous acceleration. Now, in your syllabus you have heard about that different types of acceleration. We have positive, negative, and the 0. In which case this positive acceleration can be, in which case this negative acceleration can be, in which case this 0 acceleration can be. How? Listen that. If V is more than the U, V more than the U, condition is this, listen that. V is more than the U, it means V is more than the U, it means you can say that your final velocity is more than the initial velocity. Your final velocity is more than the initial velocity. In such case, acceleration is the positive. Acceleration can be in a positive way. It means the acceleration is the positive. How it can be? Please tell me. Let us start with the one example. Suppose that you are at your home, you want to purchase something from market, just now you have started your journey, you have started from your home, this is the position, suppose that A, then your initial velocity 0 or more than that can be, suppose that suddenly you are going and your father came, said that just now go and purchase something, then you was riding a bicycle, already you was riding, then you have some initial velocity, such case can be also. It can be 0 or the already you have some velocity, suppose that you was moving, suddenly anyone entered and told you go to market and purchase something, then already you have the velocity. In a such case, but you was in hurry, just now you have started to move, paddling and paddling and paddling, you have increased your speed, then your final velocity is more than the initial velocity. In a such case, your acceleration is the positive. Which type of acceleration can be? Acceleration can be positive. Just now next case, if V is less than U, V is less than U, in a such case V is less than U, it means your initial velocity is more than the final velocity. Initial velocity is more than the final velocity. Suppose that you was moving, just now any obstacle entered in your path, then you have applied the brake, then your speed decreases. It means final velocity is less than the initial velocity. In a such case, acceleration can be negative. So such negative is, it's another name also, you have heard about that. Another name, retardation, deceleration. It is known by the two names are here, retardation, deceleration. What you have started? Decreasing the acceleration. You was increasing the change in the velocity, whatever the change in the velocity was, then suddenly it started to decrease. So such type of acceleration can be known as a retardation, deceleration or the negative acceleration. Three names: negative acceleration, retardation and the deceleration. Both all these are the same thing. If V is less than U, then acceleration is the negative. Another case, if the velocity is uniform, velocity is uniform, it means you can say that U equal to V. U equal to V, it means the velocity is uniform. Initial velocity is equal to final velocity. Initial velocity, here you have some, if velocity is uniform, U equal to V, then acceleration is 0. So how it can be the 0 acceleration? What does it mean? There is no change. In an easy way, let us listen that clearly. In a such case, if velocity is uniform, it means mathematically, just now you will see, U is equal to V, acceleration is 0. Acceleration means, you know that The rate of change of velocity is known as acceleration. Change in the velocity, there is any change? No. Whatever the velocity you have in the initial time, same velocity you have at the final position, it means there is no change. If there is no change in the velocity, then acceleration can be 0 or not. Mathematically just now, so final velocity minus initial velocity upon time t. Final velocity was u equal to v. Then in place of, you can write the, in place of v, u minus u upon t, it means u minus u, what can be? 0 upon t, then you will get the 0. How? Because in a same, there is no change at whatever velocity you have at the initial point, same velocity you have at the final point, such type of acceleration can be the 0 acceleration. Here the 3 ways of acceleration you have also find out. Just now types of the acceleration I have told you already: uniform acceleration, non-uniform acceleration, instantaneous acceleration. But here there are also 3 points you have find out. First one is the positive acceleration, negative acceleration and the 0 acceleration. Positive acceleration, just now you know that there is a change in the velocity. Negative acceleration, it means there is a retardation. Deceleration, 0 acceleration, it means the uniform velocity. In such manner you are able to find out the what exactly the acceleration is and the types of the acceleration. Just now we will talk about the, what is your syllabus? Graph, graphical representation. How we can represent the distance, velocity graph. Kinematics graphs are the 3 types. Basically you can find out the 3 types of graphs. First one is the distance, displacement versus time. Yani one type of graph can be based on the distance, displacement versus time with respect to time. Next one is the velocity versus time. Next one is the acceleration versus time. Let us start with it. We will talk about in this the nature of the object. We will talk about the cases where the nature of the object, at which position the object is, which type of graph can be here. So let us discuss one by one. Case first. When the body is at rest, the ST graph is along the x-axis. It means distance, S means the distance of the displacement. ST graph is along the x-axis. How? Why it can be? Listen carefully. And what are the examples of such type of things? Suppose that bus stop, railway station, and any train is there. So let us start. This is the origin. O is the origin. Position of the object is here. It means bus stop. You have seen the buses are here, stopped at the rest in position. It means initial velocity is 0, not moving, rest in position with respect to time passes. Time is the 1 second, time is the 2 second, time is the 3 second. In this way time passes, but position of the object does not change. In a such manner, such type of graphs, we have plotted here you on the x-axis time, we have plotted the distance or the displacement on the y-axis, that is the s denoted by this s. In this way, if the position of the object is at the point O, it means not changing, then such type of graph, the ST graph is along the x-axis. Is it clear to everyone? Next case, when the displacement is constant, here the one term displacement and the constant. What does it mean? Displacement constant. The ST graph is parallel to the x-axis. Displacement constant means, sir, what? Displacement constant. What does it mean? Displacement constant. Suppose that you have to move from your home. This is your position. 2 meter you have walked. This is a 2 meter. 2 meter you have walked. After that, you met your friend. Then you have stopped your journey. Time passes. Time is the 0, 1, 2, 3, 4. In this way, time passes. But your position at the same point, this is the point, suppose that A. At this point, your position is, you moved a little bit, but after that, you have stopped your journey. It means after that, after covering this distance, after covering this displacement, you have stopped your journey. It means a little bit, a displacement, a constant displacement you have covered. After that, you have stopped your journey. Then ST graph, when we will plot a graph, then ST graph, displacement versus time, the ST graph is parallel to x-axis. This line can be, because your position is this. Time passes, you know that time from here 0 to 1, 2, 3, 4, 5, 6, in this way time passes, but your position is the same way. Position is here. Is it clear? Position displacement constant means you have moved, but after that you have stopped. In a such way you can plot a graph. Next case, displacement time graph, third case. Just now listen clearly. Third case, the body moving with uniform velocity. Here you have seen the one term, uniform velocity. You know in a better way, just now we have talked. Uniform velocity means in a equal time interval, equal distance covered by the object, such type of velocity is called the uniform velocity. Speed with direction. Velocity means speed with direction. In a equal time interval, equal displacement covered by the object, such type of velocity is called the uniform velocity. From the rest, this is the point A, rest. It is not the little bit moved. Suppose that in the previous case, just now you have seen that little bit moved, displacement was the constant. After moving some distance, then the uniform, not like this. This is the from rest. Just now listen clearly, the body moving with uniform velocity from the rest. This is the position of the rest, O point, origin. From here to there, time passes 0 to 1, 2, 3, 4 in such a manner. Then your position of the object can be this, after that this, after that this, after that. In this way, the position of the object can be. If you will plot a graph, then ST graph is a straight line passing through the origin and making an angle with the axis. Just in the next, we will talk about the same different cases here. Just now before previous case you have seen uniform velocity was the previous case. You have started from the rest. This type of graph can be. But here you will see a body having uniform velocity with some initial displacement. Just now quote this point, initial displacement. Already you have covered some point. Already you have covered some distance. This is the O to A. Just now you have covered. A body having uniform velocity, one thing same as a previous case. Remember it. Uniform velocity was there, but from rest. Then was the straight line. Here with some initial displacement. Here initial O to A is the initial displacement, already you have covered. So the ST graph is a straight line making a positive angle with the horizontal and has a positive intercept on the y-axis. Just now in the previous case you will see same as after covering the initial displacement, it is a straight line. Next, displacement, the body moving with acceleration. Here's the acceleration. Acceleration means rate of change of velocity. Velocity is changing. Rate of change of velocity. Change of velocity, time. There is a change as a time passes. The body moving with acceleration, it means there is a change in the velocity. As a time passes, velocity changes, so the acceleration is acceleration. Why the body moving with acceleration? It means simply it have the changing velocity. At a particular time it changes its velocity. The ST graph is not a straight line, but it is a parabola, it is a curve. Such type of curve can be from initial point you have started from here, then such type of thing can be. Time passes 0, 1, 2, 3, 1, in this way time passes, but there is a change in the velocity. At this point another velocity can be, at this point there is a change, at this point there is a change. In this way different points the change in the velocity can be as a time passes. So if you will plot the graph, then you will see that it is a curve like situation. So it is a parabola. In this way we have discussed about the graph, representation of the graph, whatever was in your syllabus. In the next video we will talk about the equation of motion and how we can derive the equation of motion and how many methods we have to derive the equation of motion. Thank you everyone.